thought I'll show you some of the things that manufacturers send to me that I want to use in future videos. And honestly, I'm not sure in what order to use them. So I want your input. I'm going to show you a couple of things that I've got sitting on the shelf that manufacturers sent to me. And I want to hear from you what you want to see. And quite obviously, what gets the most votes from you guys will get the biggest attention from me. It's that simple. Now, the stuff that you see in front of the camera right now are all modules from mini circuits. I recently ordered a couple of splitters and couplers from mini circuits, and in the order process, I get in touch with mini circuits vice president Ted Heil, and it appears that he was very interested in supporting the blog. So everything that you see boxed up here, those VCOs and those IQ modulators and demodulators over there, a couple of bandpass filters here, and very interesting, we'll see this in a future video most definitely, this USB power sensor were a couple of the things that he sent my way just for us to look at. Now those couplers here I bought on my own, but I just put them in the picture so that you guys see what we're gonna work with. Mini circuits modules are perfect to show you guys how RF circuits work. You know, we got VCOs, we got modulators, we got mixers, this sort of stuff. It's perfect to build transmitter and receiver chains in modules. And after we figure out what works best, we can go ahead and design a circuit together and actually manufacture printed circuit boards for it. And that's exactly what I want to do. I want to take those things that you see on the table and a few more that I have hidden away in boxes, combine them to something useful, and build circuits on printed circuit boards afterwards with the same mini circuits parts, and do two things with that. First, I'll show you a little bit about multi-area PSK modulation. Like I said, we got IQ modulators over here and demodulators. So obviously I'm going to show you some stuff starting with BPSK, QPSK, and then higher multi-area PSK modulation modes. We're going to do something very simple probably. Start digitizing some audio, you know, normal human voice, and transmit it over the air using simple BPSK, QPSK. And we're going to up that and include things like forward error correction, a little bit of spread spectrum, just talk about things like that that are very interesting and close to what's being done nowadays. Now the second thing is quite obviously showing you guys how to design RF circuits. There's plenty of good videos on the internet how to get from the idea to a manufacturing turnkey solution that you just send off to your manufacturer and you get the circuit boards with the components on it back. But there's very few doing this with RF circuits. So my plan is actually to utilize one of these nice Lattice Mach X02 FPGAs. They're very simple to learn. I'm going to show you guys how to use them. Well, use one of those to together with an analog to digital converter, obviously, and on the receiver side, digital to analog converter. Digitize voice and send it over the airways. And what I want to do is basically get a little modular PCB that you guys can use for experimentation, where you can, for instance, say, okay, look, I want to use delta modulation to quantize my voice, send it via BPSK over the air, and then on the receive side, of course, decode that. Or you can say, okay, I want to do something more advanced. I want to actually code this audio differently, let's say PCM, and send it over the air with a spread spectrum sequence to encrypt the communication. And the modulation of all of those is relatively simple. What's going to be interesting is the demodulation. Stuff like carrier recovery and spread spectrum, the code sequence, synchronization and all that. So that's something we're definitely going to do. This has high priority for me, and we're going to look at that very shortly. This power sensor is going to be an individual review on its own. It's very nice, and you probably don't associate mini circuits with these kind of test equipment solution. Mini circuits, when you hear that name, usually think about these kind of modules or individual PCB mount devices, most definitely. But I'll show you a few of the mini circuits standalone. Well, it's not really standalone, but portable field test equipment solution too. Okay, let's move on to the next manufacturer. Freescale also sent me quite a bit of stuff, and I have to admit, my ambitions of reviewing the stuff aren't really too high. Microcontrollers are cool and very interesting, but there's just so many out there, and I personally, it does not excite me anymore when some manufacturer comes out with a exciting microcontroller or what they think is exciting. You know, every year you get 20, 30 allegedly new and revolutionizing microcontroller solutions. It just doesn't excite me. I use them, obviously, for my projects wherever needed. I'm not like some of the Arduino or PIC microcontroller fanboys tied to a certain microcontroller. I always analyze my circuits, see what I need, and then I'll pick a microcontroller based on that. But anyhow, the first thing up here is a, if I can get it open, this is a Android development platform. This is an IMX6, I believe, yeah, IMX6 development board, the MCI MX6 SL EVK. Has several SD card slots on the bottom, and I actually put in a mini PCI Wi-Fi card in there, and I didn't have a screw, or I didn't find a screw at the time, so I used a universal zip tie. Works for everything. Anyhow, we're gonna look at this. There's an Android image available for this, and I think it's flashed on the card. There's this touch screen LC display. Love it, very nice. I've played with it for a bit, but like I said, I don't really have too much ambitions to review this sort of stuff, but we're going to look at it sooner or later. Now this I find a bit more interesting. This is the Freescale Tower system. I don't know if you ever heard about it. If not, go Google it. As the name implies, it's a tower. It's literally a tower that you build up, made of several modules. There's the elevator modules that stick on the side to make it stand up. And this one's the serial module has an Ethernet interface and a bunch of I/O ports, a COM port. And the idea is basically that normally you have to buy a new development board every time you try a new microcontroller. So Freescale thought if they make this modular enough, you can keep the same tower for different microcontrollers. So I have one microcontroller board for the Kinetis L series. And over here, this is an older product, but I convinced them to send this to me. The MCF51CN128, that's a microcontroller that was designed for network applications. And we're going to play with this tower a little bit, see what it does for you, how it makes your development easier. And I think that's interesting, especially for people that normally only deal with Arduinos and PICs and similar, to actually look at some microcontrollers where you just can't Google everything if you don't know how to program it, where you really gotta study data sheets and figure out how things work on your own. And that's kind of what I want to use this for. ST Microelectronics has been supporting my blog right from the beginning. When I had almost no viewers and nobody knew my blog, just like Lee Croy, ST Microelectronics was already supplying all kinds of samples to me. So I'm very happy to see that they sent me some more stuff. What we got here is an STM32F4 Discovery board. It's, I guess, the follow-up to the STM32F3. But this board actually comes with a bunch of cool things. There's an expansion board, there's an LC display, there is a Wi-Fi interface, and there is a camera module. And just from glancing at this and looking up stuff about it on the internet, I found that this is very well documented. Of course, most of their instructions that STM provides are targeted to very well paid environments like, well, Kyle, for instance, which are just expensive, or IAR, you know, the sort of stuff that I guess there are trial versions for the hobbyist, but there's different tool chains for the hobbyist, and oh well, we're gonna talk about that in detail. But I really love this, and it's appealing, especially to the hobbyist. I know, don't judge a book by its covers, but it looks nice. It looks nice to have it sitting on the bench or on the shelf, so they definitely put in some thought. And you can tell that they definitely try to target the average hobbyist, just the way the advertisements are written and the amount of effort they put in the documentation. Usually if you're just targeting commercial users or industrial users, you do not put a great effort in it because, well, people that have to make it work for a living, they will make it work no matter how crappy your documentation is. Very sad truth. This is the Analog Discovery from Analog Devices, or well, actually it's from Digilent, but Analog Devices provides most of the parts in it and probably heavily influenced the design of this device. Basically what this is, it's a dual channel oscilloscope, has 2 function generators on board, 16 channel logic analyzer, power supply that you can control via software, especially just 2 rails that you can switch on and off. And the idea is that this is a perfect circuit for students to simulate circuits and try simple stuff. Now obviously this is not going to be a high performance device, not at all, not one bit. But it's great to simulate simple things. You know, stuff that students learn at the beginning of their electronics engineering career, like the charging curve of a capacitor, things like that. You can very well simulate and try out with this little thingy here. I bought the extra add-on connector board that gives you BNCs for the signal generator and the oscilloscope input. What I like about this the most is that it interfaces with MATLAB. I love just being able to interface stuff with MATLAB. And that's why I got this sitting on my workbench. Usually it's hooked up via USB. I got an extra hub over here on the test equipment side of the lab to connect over to my laptop on the other corner of the room. And just for simple measurements, where I need to have a quick look at something or generate something directly out of software, I do use this quite often actually. It's very nice. We will review this, we will go over the software installation, and we'll go over a couple of cool experiments to do with this. This little tiny box is a PLL locked oscillator at 11.25 gigahertz, as you can see clearly by the label. This was sent to me by a user, by Ahmed, and I really want to thank him for sending this in. He says it's functional, it does generate a frequency, but it doesn't correctly lock to the 10 megahertz reference input. So we're going to open this up, we're going to have a look inside at the circuitry, and I'll explain a little bit about how these kind of circuits work. And once we look at the circuit layout itself, I'll explain some of the things, why they are done that way, and what you need to watch when you design stuff at such high frequencies. I reviewed this on my text blog before, but I think it's really worth to shoot a video for this. This is the Apricon MEMSpeed Pro clock oscillator programmer. Basically, Apricon has a bunch of MEMS oscillators that you can program using this program. You just stick the chip in there, tell it what frequency to oscillate on, and well, it will. It's really cheap, and I don't mean cheap as in garbage, I mean cheap as in inexpensive. It's very nice to reduce your amount of crystals that you have handy. Now, needless to say, MEMS oscillators do not really have a great phase noise performance, but they're certainly nice for anything that doesn't need high stability, but a somewhat close to accurate frequency. Very nice, really, if you need several clock sources on a PCB, very easy to do. If it's not really too critical, if it's not phase noise critical, definitely a nice solution. So we're going to look at this, we're going to look a little bit at the output of one of those MEMS oscillators and discuss the phase noise performance of this against normal crystal oscillators and so forth. And the last item that I had sitting on my shelf that I wanted to show you is this beast. What is this? This is a KU-band up converter. You have, or maybe you have not seen my C-band LNB teardown video where I basically opened up a C-band LNB. C-band LNB translates the received signals from a C-band TV satellite into a frequency spectrum that your normal satellite receiver understands. And the reason we translate frequencies is primarily because the high frequencies of the satellite bands are, for once, more difficult to transport on normal coax cable, because the higher the frequency gets, the higher your loss gets, obviously. And the other reason is that there's a bunch of different satellite frequencies out there, and they just try to normalize the frequency range that a satellite receiver needs to cover. So there are different LNBs that translate all the different frequencies of satellites, the most common ones being C-band and the Ku band, into the same intermediate frequency range, usually somewhere between 900 megahertz and 2.1 or 2.2 gigahertz. So your satellite receiver only needs to cover that normalized band. Now the other side, where the TV stations broadcast the video, it's basically the same thing, just in reverse. So your 900 to 2.2 gigahertz input is right here, and this little box upconverts this into the 14 point something gigahertz range for broadcast TV satellites in the Ku band. Now this connector needs a lot more than just being fed with the 900 megahertz signal. It also needs the power through that port and a 10 megahertz reference signal to phase lock its oscillator. So since the C-band video was so famous, I think today it's still the most famous video on my little video blog. I think looking at this device is going to be very, very interesting. I'm going to do some tests on it. To my knowledge, this box is functional. I have another one sitting on the shelf. So we're going to attempt to actually modify this thing for some amateur radio purposes and see what we can do with it. I'll just play around with it for a bit and have some fun. Especially since this thing has a Ku band LNB mounted right next to it. I wonder if we adjust the frequency of the transmitter right, or maybe tweak this a little bit. We gotta see how accessible it is. If we can play a little bit with it and talk about Doppler radar and how it works. We'll see. I'm not sure if that works yet, but we'll see once we get to it. That's all the things I have sitting on the shelf that I wanted to show you. There's some few other items laying around here in the lab that we're going to have a look at, but that's the main things that I would like to hear your input about, in what order you want to hear about the things. There's a little bit of LeCroy gear we're going to have a look at. There's still the HDO 4024, the 12-bit oscilloscope we got to have a look at. Then there's a wave station signal generator. We're definitely going to talk about that. And another thing you can expect here in the coming month is a bunch of tutorials. Just talk about really basic stuff, like how to use a spectrum analyzer, how to use directional couplers to determine S parameters. And what a bunch of people asked me is if I can make a tutorial on how to read and interpret a Smith chart. So I said, okay, sure, but then let's do that with actual practical examples. Let's measure something, draw the Smith chart, and reach our conclusions from that. Okay, please post below what you want to see, what's most important to you, and of course, if you like this video, like always, subscribe to this channel, like this video, and send it out to all of your friends and the rest of the world. See you next time.